Here we're going to look at how we can plot a scatter plot using our graphing calculator. And the example that we have here says that we have the annual gross ticket sales, S, in millions of dollars for Broadway shows in New York City from the year 1995 all the way through the year 2011 are given by the following ordered pairs. So in 1995, we have $406 million in sales, and then it goes all the way up through the year 2011. So here the year is our X value and the sales would be representing our Y. Or in this case, you could think of the X would be T for time and Y would be S for sales. So that's your X and Y, or T and S for the order pairs. Well, we are to create a scatter plot using our calculator, but they want us to let T equal 5 represent the year 1995. So up here, that means that 1995, instead of using that as our X or our T value, we would simply use 5. And then 1996 would be 6, 97 would be 7, and you'd have 8, 9, and then 2000 would be 10, and then you'd have 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way up to 2011, which we would end up with, our X value would be 21 for the 1080. So let's go and put that into our calculator. So to do that, you're going to go to the Stat button, which is kind of at the top middle of your calculator here. So you enter Stat, and number 1 is Edit, so we can go in and edit. And you have L1 and L2, and you have other lists here as well. And this is where you need to be very careful. There's a way that if you have data already in here, you can highlight, use the cursor key, go up here and highlight L2, and be careful. Hit the clear button so that you clear out the list. You do not want to hit the delete key. If you hit delete while this L2 is highlighted, it's going to delete out the entire list, including L2, so your calculator no longer will have L2. You're simply going to have L1 and then the L3. So highlight L2 and simply hit clear and then enter, and that clears out all the values. Or another option is if you have a short list of values, now make sure you don't highlight the L1, you can simply hit delete and that will delete that particular value, so you can keep hitting delete. But if you go up here and highlight L1, make sure you hit clear and enter so it only clears out the values for that list. So now we want to start and put in our X values, and we said we were going to start with 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and our last one I believe was 21. So there's all the X values, or the T for the time, and then we want to use the cursor to go over to list 2, and then we want to enter in all of the Y values. So here we're going to start and put in the Y values, which is S for the sales. So 406, 436, and so on. So we want to enter all those values in. And that's where you may want to pause the video there so you can enter that into your calculator. So here we're going to put in all these values, and hopefully I won't make a mistake. So we have 406, 436, 499, 558, 588, 603, 666, 643, 721, 771, 769, 862, 939, 938, 943, 1020, and 1080. All right, so there we have all the values entered. And now we want to go to this, up the top left, it says y equals, where we put in the equation. Above that it says stat plot. So we want to hit our second function key here at the top left, and then the y equals so we can go into stat plot. And if you notice, probably your plots are turned off, so we want to go into plot 1, so you can either hit 1 or simply hit enter. And you want to highlight the on, see where the cursor is flashing. If we hit enter, then we're going to highlight the on, so that turns on the plot. Now below here, you notice we have the type of graph, and there's 6 different types we have. And if you hit the down arrow, you can go down here and hit left or right. And the first graph here is the one that we want. That is our scatter plot. So you want to move the cursor onto this first graph so that it's flashing, hit enter so we select it. Now, hitting the down arrow goes down to X list, and you should have X list should be L1 and your Y list should be L2 because that's where you typed in your values, or unless you typed your values in a different list. And if you want to change that, you would simply have to type in second function 1, that gives you L1, or second function 2, which would give you L2, or 3 would give you list 3 if you put the values in list 3. And then at the bottom here is your mark. That's just simply the symbol that it's going to use to indicate that point. I prefer to use this first one that's already highlighted, which is just a simple square box. And at this point, you could certainly hit graph, and it's going to give you the scatter plot. Now what I've already done here is typically I would go to, if you notice here there's nothing listed, I like to go into zoom. In the past I would always hit zoom standard, but because we're looking at a statistical plot, you want to scroll down to, I believe it's number 9, where it says zoom stat. So if you highlight 9 or simply hit the number 9 key, you hit enter, and it's going to give you your scatter plot. And what the calculator does is it plots each one of those points. Now, of course, we could have done that by hand, but the calculator here does this nice and neat. And by hitting that zoom stat, it's going to list or select the viewing window that's going to give us all of those points. And I'm going to simply copy this so we can paste this into our notes. And we will have the scatter plot for the year with our sales of the tickets. So here we have your x-axis again. This is the time here down here. This is our sales, the y-axis. And if you look here, the values here, if I was to draw a line through here, we could try to represent this with a straight line, and I could just guess and draw a straight line through here. And if you notice, a lot of those points are either fall on or very close to this line. So it looks like this set of data is going to represent a linear model, which would be a straight line. And we call this a positive correlation because the slope of this line would be positive. Whereas if your points were going the other way and the line went this way, it would be a negative correlation because you would have a negative slope. And if the points were kind of just scattered all over the place, in other words, if they didn't really make a line and all these points were like this, then there's really no correlation between your x and y. So here, we probably think this to be true. Over time, the number of sales in our Broadway shows here in New York City are increasing, and that would seem to make sense. Now, it looks like it does follow somewhat of a linear model with the relationship of time and the amount of sales. Well, we want to come up with an equation that will represent this straight line. Now, we could just kind of guess and estimate an equation that would represent the line, but there's some formulas and techniques that we can use to do that. And for right now, we're fortunate enough that our calculator can do that for us. So that leads us into part B. It says we want to use the regression feature of your graphing calculator to find the equation of what's called the least squares regression line that fits the data. So what we want to do here, going to the calculator, we can go into stat. Now this is going to look a little bit different. I'm using the TI-84 Plus, and I'll tell you in a minute what we can do if you have a TI-83 calculator. It's going to look just a little bit different here. If you go into second function, or I'm sorry, if you just go to into your stat, and then up here at the top, you want to highlight, move the cursor over to get calculate. And if you look at number 4, it says linear regression, ax plus b. Well, this is the slope-intercept form, mx plus b, where ax here, a is the slope, b is your y-intercept. So you either want to hit number 4 or go down and highlight number 4 and hit enter. So number 4. Now, if your screen doesn't look like this, probably when you hit linear regression, you're probably going to see something on your screen that looks like linear regression, and then you have ax plus b. Now, if you have this on your screen, and as long as you put your information in that L1 and L2, at this point you can just simply hit enter, and X list is L1, Y list is L2. The frequency, leave that blank. And I'm not going to worry about at this point storing the equation. We could store the equation, but I'm just going to simply then go down and calculate. Or for those of you that don't have the 84, if your screen looks a little different, you would just hit linear regression and simply hit enter. Now, if you put your data in something different, then you probably would need to put in the list L1, comma, L2. But if you put it in list 1 and list 2, you don't necessarily have to type this in. That's just telling the calculator that your X is in L1, your Y is in L2. But if you had L4 and L5, you would want to select that on your calculator. But if you put your information in list 1 and list 2, you can just simply hit enter at this point. And now you should see that A is 40.59 and B is 204.27. And that gives you the equation. So up here, y equals ax plus b. Your A is the 40.59. So you would have y equals 40.59 plus 204.27. And that would be the equation for the line. So if I was to copy this, and if we paste this here, this allows us to come up with this equation, and the equation would simply be y equals a, which is, I'm just going to round that to 40.59x plus our b value, which is 204, and I'll just say 0.27. There's the equation that's going to represent this line. Now, let's look at that and see if the calculator is true. Well, if we go to y equals now, we can type in that equation. And I'm just going to type in 40.59x, and it was plus, what do we have here? 204.27, 204.27. And I'm simply going to hit graph. And if we notice here, we still have all of our points, and it's drawing the straight line through the graph. So we now have a good representation of all of these points with this straight line. Now, why would we ever want to do this? Well, in real life, this is typically what you want to do. If you have a collection of some data, we want to be able to come up with a model. And when we say a model, basically here we're saying we want to come up with an equation of representing this data. And why do we want to do that? Well, this then will allow us to make predictions in the future. Say that we wanted to predict what are going to be the sales, for example. If we want to predict the sales, and let's say the year, let's see, we went up through 2011. So let's say that we want to know the sales in the year 2017. Well, if we want to determine that, we could simply then use this equation. Well, if that's the case, then that means x, which is our t value, okay, right? We said t is the x, so then if this is 2017, then that would be what? Remember we said 27? Because if we were to count up, we said that 2011 was representing 21. So if we go to 2017, then x is equal to 27. So we would plug 27 in for x. So y equals 40.59 times 27 plus 204.27, and that would tell us the prediction of sales in that year. And we could go to the calculator to do that. We could go into the table, or we could simply hit another way is second function and trace, which is calculate. And we want to calculate a value. So I'm going to select number 1, and I would type in the x value we said was number 27, hit enter, and it says invalid. Well, let's see, why is it invalid? It says invalid because if we go to our window, let's see, if we hit quit, if we go into the window, why is it invalid? Because our x max was 22.6. So I'm going to go down here and make our x max bigger. So when we went to that standard or zoom stat mode, we had this 22.6. So I'm going to change this to 30. So if we go back to the graph now, if we go into second and calculate, second trace, and we want to calculate the value, which is 1, and we wanted to type in 27, well, now that the x value, the x-axis goes all the way up to 30, it's going to accept 27. So when we hit enter, it gives us an answer of 1,300.2, so roughly 1,300. So that would be our answer. So that would be the sales, our ticket sales then would be 1,300. And remember, this is based on millions of dollars. So again, the reason we want to come up with a model is so that we can make some kind of prediction, and typically that's what we're trying to do. Now, one other thing we look at, we talked about the slope. We have 40.59. What does that tell us in relationship to our sales? Well, that says that each year our ticket sales are going to increase approximately $40.6 million. So every year, this is our rate of change. So as each year goes by, okay, we're going to increase 40 and then go over for each year. So that tells us every year we're increasing about $40.6 million in sales. Now, this is a nice graph. Again, keep in mind this is your x-axis, in this case time, or this is our y-axis, which we are representing with sales. Keep in mind if you're trying to match this up with a multiple choice question on a quiz or test, the best way to do that is go into your window, and under the window for your x minimum and maximum and y minimum, y max, set the window to match the different scales that they have on your multiple choice question. So for example, if you saw your multiple choice question, or the answer rather, for the question there, if they had the scale here going all the way down to, let's say, a negative 100 and you went up to a positive 200, then set your y to a negative 100, your y max to positive 200, and maybe your x-axis is going from, let's say, negative 20 up to a positive 15. So that's how you would want to type in the number. X minimum is a negative 20, X max is 15, Y minimum is a negative 100, and Y max is 200. And if you do that, when you hit graph, then your scatter plot then should look very similar, otherwise that is the wrong answer. So this way you can easily compare your graph if you set up your viewing window to match the X and Y axis on the multiple choice answers. All right, so keep in mind here, how do we go to a scatter plot? You simply go into Stat, Edit is where you can type in your X and Y values, and then you hit second function, Y equals is your stat plot. That's where you can turn your stat plot on and off. Now I do want to warn you, after you've done this, if you go into, and you can go into number 1 here, and you can highlight off to turn it off, or This is where you need to be careful. A lot of times later, if you use this stat plot feature, you'll forget to turn off your stat plot. If you notice when I hit Y1, if you have where you type in your equation, notice at the top it says plot 1 is highlighted. Well, that means your plot 1 is turned on. So from this screen, if you were to hit graph and you're trying to graph another equation and you don't want to see the stat plot, for example, when we hit graph, if you don't want to see the scatter plot and all we want to see is the straight line, then if you go to y equals, if you use your cursor to highlight plot 1, hit enter, and that will turn it off. So if I went down, notice here plot 1 is no longer highlighted. And a lot of times people run into trouble after they use this stat plot because they'll be trying to graph other equations and all of a sudden they hit graph and they get some kind of error message saying the dimensions do not match. Well, it's a good chance then you left one of these plots turned on. So if I turn off this plot now when I hit graph, notice all I'm getting is the straight line. It's no longer plotting the points. So keep that in mind as you go through, and once you're done with the scatter plot, it's probably a good idea to go in and turn that scatter plot off. Otherwise, you may get an error message in the future when you're graphing other equations.